Another question on linear equations. You have set of linear equations where alpha, beta, gamma are real numbers, which are of course not known to you. You have to match list 1 to list 2, and you see what they are giving you. See, they are giving you beta, gamma, and then they are looking for whether you have a unique solution, no solution, infinitely so many. Okay, so what do you do? Like if you try to tackle each one of them at a point of time. Okay, you have to say that determinant is not zero means a unique solution, right? Okay, if determinant is not zero, you mean a unique solution. If determinant is zero, that means it can have infinitely many solutions or no solutions. What we are going to do is just try to see how we are going to tackle in just one go all the questions. Okay, you're just going to write the coefficient matrix. Okay, you know what's a coefficient matrix? First equation, if I write, I will just write 1 2 1, and the right hand side along I will write a 7. Second equation, 1 0 alpha and an 11. Third is 2 minus 3 beta and gamma. So virtually what I'm going to do is I'm going to write the equivalent set of equations, right? If I just do some operation, let's say I try to make this 0 and this 0. Okay, how do I do that? I will just do that R2 is R2 minus R1, and I will do R3 is R3 minus 2 times R1. Okay, just do that and see. This is what you get, right? You got a 0 here and 0 here. That means the coefficient of x is 0 now. See, you have equivalent set of equations. It's the same set of equations, equivalent we call it, but just that in second and third equation you no more have x in it, right? Okay, now maybe we'll simplify this a little bit more by doing R2 by 2 and R3 by 7. Okay. This is what you end up in getting. Okay, now what next? I want now this guy to be 0. Why? Because in the third equation I just want to eliminate even the coefficient of y. X already is 0. What do you do for that? You just do R3 minus R2. You take help of R2 and you just write down. So these are three things which you have to think. Minus 1 minus of minus 1, that's 0. Beta minus 2 by 7 minus alpha minus 1 by 2. Okay, just do it on the side and check if you're getting 2 beta minus 7 alpha plus 3. That's what you will be getting, divided by 14. And if you do gamma minus 14 upon 7 minus 2, you will end up in getting gamma minus 28 upon 7. Okay, now we are all set. Okay, to answer all of the questions. So you see one by one. Let's go to first one. It says that beta is this. What does that mean? 2 beta minus 7 alpha plus 3 is 0, right? So that means, you see, what are they saying? That this is 0. Even gamma is 28. That means this is also 0. What does that mean if both are 0? You have infinitely many solutions, right? The third whole row is going to 0. Okay, that would mean, in other words, if you have seen this, that delta is 0, delta x, delta y, delta z. If you know what these means, they're all 0. Okay, you can also just quickly infer, if one of the rows are getting to 0, that means you have infinitely many solutions. Okay, so this is matching to third one. Now look at the Q option. It says that beta is this. Okay, that means again this is equal to 0. But gamma is not 28. That means this is not 0. This is ridiculous, right? You're saying 0 is equal to something which is not 0, right? Okay, that means no solution again. In other words, you can see you are saying that delta is 0, but these are not 0. Okay, so again, you don't have a solution if that is the case. Look at the third option. It says that beta is not this. That means again this is not 0. Okay, and they're saying gamma is not 28. Let's for the time being, let's not look at this. Gamma is not 28. That means this is also not 0. Okay, that means perfect. Okay, that means if this is not 0, that means you have a determinant is not 0. That means definitely you are going to have a unique solution. Since this is also not 0, I need to know what is my gamma then, right? If it is not 28, what it is, then only I will be figuring out what is my z. Correct? Okay, that means I know it has a unique solution, but I don't know what it is. Okay, even though I am given alpha to be 1. So I'm just going to say that it has a unique solution. I'm not sure which one it is. Look at option number S. It says that this is not 0. Okay, so this is not 0, but this is 28. Okay, so that means we are saying that this is equal to 0. Okay, if this is equal to 0, that means what kind of equation do you form? This is not 0. Okay, let's say it is something, let's call it maybe p. Okay, p times z. Okay, because this whole thing, let's say it's p, which is not 0, times z is equal to 0. Okay, that means what? Z is 0. That's your solution, right? Now you got z is 0, you come back to this equation. Okay, you come back to this equation. What does minus 1 means? It's a coefficient of y plus this times coefficient alpha is 1. Okay, so there is no coefficient of z, you get a 0, is equal to 2, right? The right hand side. That means what is your y? It's minus 2. Okay, similarly you can figure out what is your x from this equation, but no need, right? Because only this option says that your y is minus 2 and z is 0 is the solution. You can figure out from here that you should be getting x to be 11, so your s is going to 4. So of course we got, right, a is the correct option. Okay, so you just do the equivalent matrix thing by doing row operations, and you're all set to answer all of the questions. Okay, nice question. See you with another one.